Hello, everyone. Today we're going to answer this question. What makes a good scientific question? How do you ask good questions in science class? So in science class, whenever we ask questions, we're always asking questions about a phenomenon. So a phenomenon is, for example, it's just anything we're trying to figure out, right? Anything we were trying to understand better to understand how it works, right? So for the purpose of this presentation, the phenomenon we're going to look at is the phenomenon of the wildfires that are occurring in Australia, right? So we could use different things to start thinking about these phenomenon, right? Like a photo of this kangaroo by the fire, data around where the wildfires are taking place, or data about the rising temperature, a graph about the rising temperature in Australia, right? All ways to help us start thinking about this phenomenon and asking questions, right? Remember, asking questions is like the first step in the scientific process, right? So all good scientific questions have three components, three requirements. Good scientific questions should, number one, address the phenomenon or the problem under investigation, right? So if this yellow bullseye represents the phenomenon, all of our arrows, all of our questions should hit that bullseye, should be about that phenomenon. In other words, the question should be on topic, right? So if you look down, you have this table on your notes, right? There are 4 questions on this table. What I want you to do is read each question and identify, does it address the phenomenon under investigation? The phenomenon that we're talking about right now, like I said, is the Australian wildfires. So pause the video, fill in these blanks, and then restart the video to see if your answers agree with mine. Okay, so the first question says, how has the amount of rainfall this year affected the number of wildfires? Yeah, this is definitely about the wildfires in Australia, right? So the answer for that one would be yes, it does address the phenomenon. Second question says, what can firefighters do to fight the fires most effectively? Also about the fires, right? So yes. Where is the best place to surf in Australia? Well, this is about Australia, and Australia is part of the phenomenon, but the phenomenon is the wildfires in Australia, right? And this has nothing to do with the fires in Australia. So no, this one would not address the phenomenon, which makes it not a good scientific question. And last but not least, are birds being affected by the fires? Yeah, this is also about the fires. So yeah, that would be a great question to ask. It does address the phenomenon that we're investigating right now. So number 2, what else should good scientific questions do? Good scientific questions should be empirically testable. Okay, so what does that mean? What does it mean to be empirically testable? Good scientific questions should be able to be answered using experiment or experience. So experiment and experience are 2 very similar words, so it's really important we understand the difference. So either a question should be able to be answered using experiment, which is like what we've been doing in class, right? You choose an independent variable, a dependent variable, you test them, you collect data, you analyze the data, you answer your question, right? That's an experiment. You design an experiment, you run the experiment, and you conclude your answer to the question based on the results of the experiment, right? Or through experience. A lot of times questions, you don't need to actually run an experiment for it. You just have to go and find the answer. You have to go observe, right? So the reason I put this picture on here to represent experience is because experience is frequently observation. Like you go and observe something happening in nature, you observe something happening in this situation in Australia right now, right, in order to answer your question. Experience could also imply that you're talking about something that's happened in the past, and you're going to go figure out, you're going to go learn from someone else's experience, from what someone else observed in the past, or from someone else's data they collected in the past in order to answer your question, right? So experience could also be talking about something that already happened, and you're trying to figure out what already happened in order to answer your question. So all scientific questions should be empirically testable. You should be able to explain how you could answer your question using an experiment or using some sort of experience, right? So right here you have another table, right? On this table you have 4 questions. For each question, I want you to answer how you could, or I want you to answer in this section how it could be answered. How could you answer your question using an experiment or using an experience? So the first question says, how has the amount of rainfall this year affected the number of wildfires? Right. So my question is, how would I be able to answer that question? Well, I guess I would need data about the amount of rainfall, and then I would need data about the number of wildfires, and I want to compare the data to see if there's a relationship, right? Either, no, I could answer this by experiment or experience. Either I could run the experiment myself, I could collect all the data, or through experience, I could find someone else's data they've already collected and compare it that way. Either way, I'm able to empirically test it. I'm able to find out the answer through experiment or experience. So I wrote here, I could compare data that shows the amount of annual rainfall in Australia with data that shows the amount of annual wildfires in Australia, right? That's how I would answer that question. For the following 3 questions, guys, I want you to answer how you could answer it using experiment or experience. There is one of these 3 questions cannot be answered by experiment or experience. For that question, you can just write cannot be answered, because that means it's not a good scientific question. So pause the video and do that. Last but not least, number 3, all good scientific questions should be classified into one of 4 categories. These 4 categories are observational questions, explanatory questions, systems questions, and engineering questions. What does that mean? Okay, so first off, guys, observational questions. So observational questions are questions of what you're noticing. I want you to think of observational questions as kind of like your very first questions you have when you're first examining a new phenomenon, right? It's the questions you have to get answered before you can move on to more to deeper questions, right? So an example of this, right? You look at the picture of the wildfire with the kangaroo and you ask the question, is that a kangaroo in the picture? Maybe you're looking at an ocean current map and you ask, do the red lines on the ocean current map mean something, right? They're questions about things you're noticing, generally things you're noticing with your 5 senses, right? Generally, guys, as a teacher, when students ask me observational questions, those are questions that are generally easier to answer. Doesn't mean they're not important. They're very important, right? Because you need to answer those questions in order to understand the phenomenon. However, they tend to be easier to understand because they're kind of just like often are yes or no, or they're very straightforward answers, right? But they're still very important answers about what you're noticing with the phenomenon. The second type of question are called explanatory questions. So explanatory questions are questions that are related to cause and effect or how things work, right? Generally or frequently, explanatory questions start with why or how. So examples being, why are the fires mainly in southeastern Australia? How does the fire spread, right? They're questions that are related to like what's causing what, how is it affecting this, how do things work, how does this work, right? Generally, as a teacher, guys, these questions are the ones that are a lot more difficult for me to answer when students ask them, right? Because they tend to involve much more explanation, hence the word explanatory, right? You really see when a student asks this type of question or a scientist asks this question, they're really trying to understand how something works or why something does what it does, right? Those are explanatory questions. Systems questions are questions about parts of the system. So really important, before you write in your notes, I want to make sure you hear this. Remember we talked about how systems are like what you're focusing on in your study. It's what are you studying? So when it comes to Australian wildfires, the system that we're focusing on, I would think would likely be Australia, right? And we're looking at what enters the system in Australia, what leaves the system in Australia, but we're focused on the system of Australia. So a question about what else is in that system, I get asked questions like, what is happening to the birds right now in Australia? Or in Australia, how many acres of forest exists there? Like how much of Australia is forest? Is it 90% of the continent or is it 30% of the continent, right? I'm asking questions about the system. So before you have to ask a systems question, you first have to think about what is the system we're talking about, right? In this case, the system is Australia. So I'm asking about parts of that system that potentially are being affected, right? Like the birds or the forest, whatever. And last but not least, guys, the 4th type of question is an engineering question. Engineering questions are always about solving a problem. We've learned that engineering is using science to solve problems, right? The same way, embedded in any phenomenon, you can always find problems that need to be solved, right? So questions around this are all about solving problems. So example could be, how could we use ocean water to put out the wildfire? Or is it possible to build a wall to prevent the spread of the wildfire? Right? Both of those questions are about like solving a problem related to the phenomenon. All right. So on your sheet, you have a list of 8 questions. I want you to categorize those 8 questions into what type of question they are. So write an O if it's observational, an EX if it's explanatory, an S if it's a systems question, or EN if it's an engineering question. We're going to do the first 4 together. You'll do the second 4 on your own. First question says, how has the amount of rainfall this year affected the number of wildfires? So once again, this starts with the word how, which is a hint for us, right? It also has the word effect in it. So it sounds like we're talking about a cause and effect. And if you just back up a little bit and think about it, it's asking you to explain something, right? You're trying to explain how something affects something else, right? So this would definitely be, if you look back here, starts with the how, about cause and effect, how things work, right? It's definitely an explanatory question. Second question says, what can firefighters do to fight the fires most effectively? Here we're identifying some sort of problem, right? The problem is that fires, I guess, aren't being fought effectively. So what can firefighters do to fight the fires most effectively? That is definitely trying to solve a problem, right? So that would be an engineering question, EN. Thirdly, it says, are birds being affected by the fires? This one, once again, I've already used this as an example, right? But we're talking about the system of Australia, and we're asking, are the birds being affected? The birds are just part of the system, right? They live in Australia, they're part of the system. Are they being affected, right? I'm asking about something another part of the system. That's a systems question. Last but not least, guys, the question says, is the kangaroo in the picture pregnant, right? This is like a simple yes or no. It's based on observations. In the picture, it looks like it's pregnant. My question is it pregnant, right? That's what I'm noticing. Is it pregnant? That's an observational question, right? Go ahead, continue with this with the next 4 questions, and then pause the video until you do that, and then restart the video to move on. All right, now what you're going to do, guys, now that you've learned the 3 requirements of scientific questions, you're going to go to Google Classroom. At Google Classroom, there's a list of articles that are all related to human impact on the climate. You're going to choose an article, and actually choose 2 articles, and then you're going to read it, and then fill in and ask 4 questions about that article by filling in the question graphic organizer that's been given to you. Note that some of the websites might require you to log in with Google in order to access the article. So these are the articles. There are lots of different topics. You can choose ones that interest you. Alternatively, you can choose ones that are more simple or easier to read, or ones that are more difficult to read, depending on what you like to do. The Lexile score right here, the lower the score means the easier it is to read. The higher score means it's a little bit difficult. But I would encourage you to do one that you think challenge yourself, but also choose a topic that interests you and choose an article from there. You're going to fill in this graphic organizer, guys. On this organizer, you have the 4 different types of questions. You're going to write at least 1 question in each category, and then explain how you could empirically test it in the right-hand box for each category. Okay, you're going to do 2 articles. The reason we're doing all this, guys, is we're working towards a summative where you're going to be assessed on how well you ask questions. And this is what the rubric on that summative is going to look like. For that summative, you're going to be given a phenomenon, and you are going to have to ask 4 questions, 1 for each topic, one for each type of question, right? Observational, explanatory, systems, and engineering. To get a 4, all 4 of your questions should address the phenomenon, be empirically testable, and be correctly categorized into the 4 question types, right? That's what we're working on. It's okay if we don't get there today. Today's all about understanding how we categorize questions, how we ask good questions, but are working towards the goal of being successful on this rubric. Go ahead, guys, and get started. Choose your article and get started filling out your graphic organizer.